No ways this will help anyone. No. This is not good enough. Let's talk maths and get a good understanding what maths is about. Firstly, no mathematician, no scientist, no philosopher really know what this subject matter is about. So what we do, we study something intensively without really knowing what we're studying. But let's try. I would say it is a universal philosophy. It's not a natural science. You don't find it in nature. You can't do any experiments. You can't go into any physics labs to discover mathematics. It is born from the mind of people. They consider physical phenomena, they consider all kinds of other bodies of science, be it law, be it philosophy, be it economics, be it humanities. Mathematics is simply the study of patterns. It is meant to serve as the queen to all sciences. Bear in mind that it's firmly believed that the gene giving you the ability to learn your mother tongue so that you can speak it, read it, write it, understand it reasonably, it's exactly the same gene that will give you the capacity to do mathematical thinking. So any one of you who can talk today reasonably well in your mother tongue, inherently you are a mathematician. It is just that people do not succeed in bringing the mathematics inside you out. What we're going to try and do is not to pump mathematics from a blackboard into your mind. We're going to try to get the mathematics in your mind onto our own blackboard. Mathematical thinking has been demonstrated about 44,000 years ago by a surprising group. This group, there's a group of African ladies near the Lobombo Mountains, the mountains separating South Africa from Swaziland. And if the thinking is correct, African ladies were in fact the first real mathematician walking planet Earth. How they discovered it is that the Lobombo bone, the fibula of a baboon, carried 29 little notches, and they were wondering what the meaning behind this could be. They linked it up successfully with the lunar cycle, and that became more fascinating. One would like to understand why the lunar cycle itself was so important to record and to have ready as a handy tool of kind. Now the thinking is that there was an understanding that a woman's menstrual cycle ran on some fairly close, if not fixed, kind of cycle, and that these ladies wanted to know and wanted to predict the next cycle and the beginning of menstruation. One can wonder, was it simply because of menstrual pains, of the what could have been perceived a dreadful bodily event, or was it even more smarter than that? Because ladies are smart, let me tell you. Was it so smart that they realized it coincides with impregnation? Was it an early form of birth control? Was it linked to desirable, less desirable seasons at the time? That's open to speculation. But what is very, very clear is that this was perhaps and most likely the first demonstration of mathematical thinking, finding embodiment in something physical, which we then call mathematics. So the moment you symbolize your thinking, ready for other people to consider, you then engage in mathematics. Make no mistake, earlier bones carrying notches were discovered as early as 80,000 years ago. But all attempts to get some understanding of a logical or plausible pattern in these notches continuously simply escaped human beings. So we are back at the Lobombo bone as a demonstration of the first ability of humans, specifically women then, to demonstrate mathematical thinking. The other very natural thing that happened is that people considered when do they have how many of certain things. And in nature, if there's nothing of a thing, they thought it's not worth thinking about it, there's nothing to think about. So the zero as we know today remained non-existent for many, many years. But the idea of having one of a thing, two of a thing, three of a thing, etc., that came to mind very quickly. and they were simply symbolized through various number systems over ages. And what we use today and the symbols we have for a 1, 2, a 3, etc., is the worldwide adoption of what is known as the West Arabic number system. Because of these numbers beginning at 1, hopping over to 2, hopping over to 3, because they share this common feature that you have those quantities of physical somethings out there, nothing in between, the concept of fractions remained absent for many, many, many years. The idea to acknowledge this group as a unique group sharing a particular feature was then born, and because they mainly counted things in nature, it was fairly common sense just to refer to them as natural numbers. The important principle and the important understanding for all of you out there today is that none of the things I've mentioned thus far, and nothing of the things I'll mention later on in this series, can be discovered scientifically. The mere fact that mathematics describes science, describes engineering, describes technology, describes most other bodies of knowledge fairly well, doesn't make it a natural science itself. I hope to demonstrate this with the rest of my chill chat in my maths chill room, when we're going to speak about some nice observations linked to a famous theorem called Pythagoras' theorem. I'm sure most people have heard of this theorem somewhere in the distant past.